Modern smartphones are millions of times more powerful than those computers humans used to land the first people on the moon. Just imagine how powerful our technology will be in 50 years. Today, we're talking with someone on the cutting edge of new technology, Dr. Ashley Williams. Dr. Williams is an engineering manager at Apple, where she leads a group doing modeling and simulation for research and development of brand new technology. Her team recently made a huge announcement about technology they developed to let iPhone 14 talk to satellites. Thanks so much for talking with us today, Dr. Williams.
Thank you. I'm so happy to be here.
So that project for the phone satellite communication is so exciting, and I want to talk more about it. It's called Emergency SOS via Satellite. Can you tell us more about it?
Sure. So Emergency SOS via Satellite is a groundbreaking feature available on the iPhone 14 lineup. We developed it with the simple idea that when you need help, you need it wherever you are. And sometimes those moments include when you're in an emergency and are out of cellular or Wi-Fi range. We saw satellite connectivity as an important way to extend Apple's existing set of safety features. Previously, connecting to a satellite required a dedicated device, which was catered to users who wanted to pay for them and invest the time and the effort to learn how to use these devices and then to carry a secondary device. For most people, like a casual weekend hiker, a dedicated satellite device just doesn't make sense. So with the launch of this new service, this technology is now built into the iPhone 14 lineup, and it has already saved lives.
So what kind of people are working with you on these teams?
So I am lucky to work with people across Apple with super diverse backgrounds. My direct team is made up of software developers, analysts, and data scientists with backgrounds in physics, wireless communications, and aerospace engineering.
So to help me and others understand exactly how this works, could you tell me, how does your phone usually connect to Wi-Fi or send a message?
So phones normally connect with terrestrial cell towers that are usually within a few miles. You can often see them along the freeway disguised as trees.
Sometimes my phone tells me that I don't have service. What can cause that?
That occurs when you are too far from a cell tower to connect, or when you are occluded by terrain or large buildings. This is why you may have poor service in the middle of a big city surrounded by skyscrapers.
So your team has found a way around being in regions where you don't have cell service by connecting to satellites. What's different about the process connecting your phone to a satellite?
So the biggest challenges are that the satellites are very far away, hundreds of miles, and moving very fast. This means the signals are weaker than for traditional cellular communications, and we must also account for Doppler shift. This has to do with the fact that the satellites are moving, and so we communicate with the satellites at a particular frequency, but depending on how they're moving, we adjust that frequency a little bit. This is the same phenomenon that you might observe when you see a train. As the train is approaching you, it sounds different than as it is moving away from you, and that is due to the way the frequency changes from the Doppler shift.
Wow, yeah. I hadn't even thought about how that change, that Doppler shift, would affect your connections to satellites. That's really cool to hear. Is there anything special about the satellites your phone can use?
So enabling satellite connectivity on iPhone 14, we sought to use satellites already in orbit, and this was an incredibly challenging effort. It required us to develop custom technology and to optimize both the iPhone and the satellite to ensure reliable two-way communications.
How many satellites are up there?
So in general, there are thousands of communication satellites. Some are in geostationary orbits, meaning that they remain in the same place in the sky, while others are in LEO, or low Earth orbit, that's typically about 1,000 kilometers above Earth's surface. But Emergency SOS via Satellite utilizes a constellation of 24 satellites managed by a company we partner with named Globalstar. Globalstar satellites utilize frequencies that have established regulatory approval for use between satellites and mobile devices such as iPhone.
It sounds like a really interesting project that you got to work on. I'm wondering if you could talk a little bit more about your particular role.
So my job is to understand the system end to end and to develop modeling and simulation tools that allow us to predict how the system will work in certain situations. And then we use that information to influence technical decisions.
What kind of skills do you think you need to work on something like this?
So there is a lot of math, physics, programming, We also need to be very creative thinkers and innovative problem solvers that can either build a super detailed simulation or simplify this incredibly complex problem into a back of the envelope calculation to determine the impact of different options. So we have to be able to do both.
I feel like when people talk about engineering, I always think about building bridges or skyscrapers. But this sounds like a really different kind of engineering. Do you think of it that way?
Yeah, so this is 100% engineering. When I was younger, I thought of engineering how you described it, as either building things or maybe even taking things apart. But I later discovered that engineering can also be incredibly abstract. And so the engineering that I do is mostly in my head, or it's on a whiteboard or in simulation code, but it is still 100% engineering.
Thank you so much for talking to us today about your work. I'd love to get to know more about you and how you got to where you are today. Where did you grow up?
I grew up in Colorado, in a suburb of Denver. I lived in Colorado throughout my undergraduate education at the University of Colorado at Boulder. I then moved to Los Angeles to attend graduate school at Caltech, and I stayed there for the first part of my career. Later, I moved to the Bay Area to work at Apple in 2018.
How did you get on this path? Were you always interested in a STEM career?
So I always really liked math. I was in middle school when the movie Apollo 13 came out, and I loved it so much. I was just in awe of the engineers. That was the first time I thought, wow, I want to work for NASA. For a long time, though, I didn't think I could be an engineer. I didn't think I was smart enough. When I went to college, I thought, well, maybe I could do PR for NASA. So I originally intended to double major in aerospace engineering and communications, but as luck would have it, all the communications classes were full my first semester, so I only took engineering classes. I worked really hard and I surprised myself and did quite well. So that's when I started to realize maybe I can be an engineer. And then along the way, I had teachers and mentors who really believed in me and they encouraged me, and I just kept going. And eventually, I did end up working at NASA at JPL on my PhD research on the optimization of spacecraft trajectories.
Wow, that's incredible to hear. Really glad you kept going. So you seem like you've done some really cool things, but I know that at least for me, there's always some bumps in the road. Is there a time that you can remember where things got really hard or you almost wanted to quit? How did you deal with that?
There have definitely been hard times, but I've never thought of quitting. Over time, I built up the confidence in myself that no matter how hard things get, I trust that I can get through it and that I can figure it out. I'll give you two examples. The first was when I was finishing my PhD. My thesis advisor passed away about 9 months before I was set to defend my thesis. And it was 6 weeks before my defense, I realized there was a major flaw in one part of my research, and I had to derive a new solution from scratch. I worked 15 hours a day for 6 weeks straight, and it was the type of mistake that my advisor would have spotted right away months previously. So I learned a lot about perseverance and maintaining a singular focus to achieve my goals. More recently, I returned to work after maternity leave with my first child. My baby wasn't sleeping super well yet. He's still not sleeping super well. And I was still figuring out how to balance work and caring for my baby. My first week back full time, I had a really important presentation coming up. And so every night I would come home from work, I'd take care of the baby, put him to bed, and then I'd start working again. I would be just so engaged. I would just keep working and working. And then it would be time for the baby to wake up for one of his night feedings. It was the most tired I have ever been. But I also found these moments of clarity in those middle of the night sessions. There was one time that I came up with a genuinely good simulation idea at 4 a.m. that I'm still using today.
You're such an inspiration for young scientists and to me. Do you have any advice for young people who are thinking about setting off on a similar path as yours?
Learn the fundamentals, math, physics, programming. Really learn how to problem solve and to think abstractly, and then take an improv class or a theater class. I think it's a great way to develop presentation skills. And then when sharing technical information, remember to tell the story. There is always a story. And then develop good people skills and really take the time to develop collaborative relationships with colleagues and teammates. We can achieve so much more together than we can alone.
Finally, as we wrap up, I would love to hear your big picture thoughts on imagining where tech will be in 20 years. What do you hope or dream we might be able to do with the technology that you and your team are developing?
So I'm very excited that the work we put into emergency SOS via satellite is now contributing to saving lives. Outside of that, you're just going to have to wait and see what we dream up next.
Thank you so much for talking with us. I can't wait to hear more about what you and your team accomplish as technology keeps getting better and better.
Thank you so much. I really enjoyed talking with you.